So very quickly, and those of you that were away, the notes are online. You can get them later. Don't fill out the missing notes and miss the current stuff. Never fall behind trying to get caught up. I'd rather have you stay with the current stuff and then get the stuff you missed later on. But here's what I said. My argument was, I said, I can handle any conversion with one method. And yes, there are plenty of shortcuts. And Courtney, if you want to memorize a shortcut, go ahead. I'm fine with that. But what I am saying is, I always start by writing down what they gave me. And then I build a conversion fraction chain. I say to myself, the units I want to get rid of, are they on the top or on the bottom of this first fraction? Then they're going to be on the bottom. If they're on the top, they'll be on the bottom of the next fraction. If they're on the bottom, they're going to be on the top of the next fraction. And by doing that, it answers the question that most kids ask me, which is, Mr. Dueck, do I divide or do I times here? How do I go from hours to minutes? I don't know. It's something to do with the 60. Do I divide or do I times here? I don't need to worry about that. I can let the fractions tell me. And it also lets you tie in, Alex, to stuff you already had memorized, but you don't have to memorize useless crap. Okay? So we were looking at these multi-step conversion factors. How many seconds in 1 week? I wrote down what they gave me. 1 week. I said week is on the top. It's going to be in the bottom of the next fraction. And I said I can break weeks up into days, and I have that conversion factor memorized. We said it even works for stuff that we're not that familiar with. We did a couple of questions in the imperial system, in the US system, that are in the non-metric system. And it also worked equally as well. I didn't expect these answers. 5,280 feet in the mile is a stupid conversion factor. I won't make you memorize that. If I asked you it, I would give it to you on a test. And then we left off looking at Gloria Mackenzie. So we can even use it for this. It says, Gloria Mackenzie won $590.5 million on May 18th, 2013 in the Powerball lottery. If she spends $1,000 per day, how many years will it take for her to spend the money? I'm going to guess that all of you have occasionally seen a big lottery prize and just kind of wondered, like now here in BC, I think we just recently had the biggest one I think last week for Lotto Max was like 60 million or something like that. How much is that? Or here, okay, 590.5 million. How much money is that?
A lot.
More specific, how fast would you spend the money and still be able, well, let's start. $1,000 per day. Now, here's what I want you to do. Somewhere off in the margin, no one else is going to see this, write down how many years you think it would take her if she spent $1,000 per day. Make a guess. How long would it take to spend $500 million, $590.5 million, if you spent $1,000 a day? Make a rough guess. So put a guess right there somewhere. Just for giggles to see how good your gut instinct is, not for any particular right or wrong. Okay? Let's convert this. How? How did I start out every single other question? How do I start every single other question? First step. I'm going to write down what they gave me because it's no longer blank. They gave me 590.5 million. Now I'm going to make one slight adjustment. I'm going to go like this. 590.5, I'll put a dollar sign because that's the units. I think I showed you a video about dollars and cents last class. Yes, that made a difference. Million, Matt, I know that that's times 10 to the 6th, so I'm just going to add that. You could add the zeros, but you may have picked up I tend to abbreviate. I'm always looking for shortcuts. I know that 1 million is 10 to the 6th power. That's 590.5 million. So I wrote down what they gave me, but instead of writing the word million, I mathized it, if that's a word. Times. Then there's this if. What is this if? Turns out this is a conversion factor, $1,000 per day. I'm going to go like this, except I have to think a little bit here. You see, I want dollars to cancel. Dollars is on top. Where is dollars going to be in my next fraction? I'm going to write it like this. $1,000 is the same according to this as what she spends in 1 day. Now that is counterintuitive. A lot of kids, because it's per day, they think the days should be on the bottom and they would want to times by 1,000. Am I going to times by 1,000? I think I'm going to divide by 1,000. That would get rid of dollars, boom, boom, and leave us in days. This would tell us how many days it would take her to spend this money. What do we want our answer in? Do I have a conversion factor that relates days to years? Oh, I do. Then great. Then I'm going to be done in my next line. Where is days going to go in the next conversion factor, on the top or on the bottom? I want days to cancel. I want years up there. What's the conversion factor? 1 year is... That is fair game for you to memorize. That I'm going to, growing up in North America, I am going to say it's fair game, memorize our calendar. Those 365 days of the year. Okay. Apparently that'll give us the answer. How many years spending $1,000 per day would get you? Could she spend it in her lifetime at that rate? What do you get? I think it's stunningly big. What do you get? Yeah, she's not getting this spent. This 1,600 is 18 rounded off properly, or is it 17? Is it 18 or is it 19? 18. So she can spend $1,000 a day, and she'd be spending until the next millennium. Oh, hang on, 1,000. I got an extra 8 in there. Oh, extra 1 in there. That, yeah? Sorry, guys. Years. And my argument, again, Courtney, is by planning my conversion factor approach, I knew that, oh, it's divide by 1,000 and divide by 365, not times. Which is really most of the time the question kids are wondering. So clearly $1,000 a day is not enough. How about $500 an hour? Now that would be tough to do, and we're going to say 24 hours, like 24/7, which was kind of tough to do because you'd have to sleep. But maybe she set something up automatic. She buys $500 of stuff from Amazon every hour automatically. How long would that take? How am I going to start? Again, going to write down what they gave me. 590.5 million. Here, the conversion rate, now again, I want the dollars to cancel because I want to end up with an answer with time. So I'm going to put this 500 is going to go on the bottom to cancel out the dollar sign that's on the top. And it's for 1 hour. And that would cancel out dollars. This would tell me how many hours it would take her to spend this money. What can I go from hours into? Days? That one I got memorized. Where am I going to put hours in my next fraction, on the top or on the bottom? Bottom. Days is going to be on the top, and I think it's 1 day is 24 hours. So I'm already seeing, I think I'm going to divide by 500 and divide by 24. Can I go from days to years? Yes, I can. I have a conversion factor. It is days, years, 1 year, 365 days. Okay, if she spends $500 an hour, can she spend that in her? By the way, did anybody guess in the thousands of years for part A when I told you to guess an answer? You did? I'm impressed. Like, it's this amount of money is far bigger than most of us can wrap our brain around. I think if I was a good teacher, I would have showed you some video about pennies or something like that with millions and billions and trillions to help you wrap, and even that, I can't quite wrap my brain around. Okay, so Mr. Dueck, let's see. How many years will this take? 590.5 times 10 to the 6th, there's my million. Divide by 500, divide by 24, divide by 365. Ooh, 134.8 years. She's still not able to spend that in her lifetime. Well, let's kick it up a notch. Let's spend more. Why not? Little note, according to Wikipedia, she actually, and I think I mentioned this last class, if I didn't, the way lotteries work, so let's suppose, Alex, you won $60 million in the lottery, okay? They'll give you a choice. If you want the full $60 million, what you'll get actually is you'll get it paid out over 25 years. So 60 divided by 25, they'll spread it out. Or you can take a lump sum payment up front for less than $60 million. They'll say to you, you can take less money right now, all of it. So, hey, we'll give you $38 million right now. Or you can get the full, because a lot of the money comes from interest. Okay? Why would you take less money up front? Well, if you're 70 years old and you win the lottery and they tell you they're going to pay it off for the next 25 years, do the math. Probably not going to be around to collect, right? And most of the time, people that win the lottery are not 19 years old or 20 years old, usually old. So a lot of them take the money up front. So this gal, what was her name? Gloria, she took the lump sum payment up front, which was a single payment of $371 million. And I had to add this, because she lived in Florida, she paid no tax on it. If you win a lottery here in BC, pretty much half of that you'll lose right away going to taxes. So she didn't have to pay any tax. That's high. Okay. And she wants to spend $10 per minute. Okay. How am I going to start? I'm going to write down what she has now. This time it's 371 and million. It's easier just to go times 10 to the 6th. Now, our conversion factor, $10 per minute. Again, I want the dollars to cancel, so that's going to go there. And up here is going to go 1 minute. We want to end up in years. Anybody know how many minutes are in a year? No? Well, let's keep building our chain. What can I go from minutes into? Hours? Sure. Minutes is going to go on the bottom here. Hours is on the top. 1 hour, 60 minutes. I know that from growing up. Do we know how many hours are in a year? We might have, I think we actually calculated that earlier in the lesson, but let's pretend we didn't have it just to refresh our memory. What can I go from hours into? Days, you say? Hours cancels. Days, 1 day, 24 hours. And what can I go from days into? We're home free. Here it is. Days, years. So it looks like it's going to be 371 times 10 to the 6th. Divide by 10, divide by 60, divide by 24, divide by 365. I think this one is the first one that's doable. I was trying to do these in my head, kind of rough guess, when I was making up these numbers. I hope my estimation math is right. I think this one can be done in a lifetime. $10 a minute. 371 times 10 to the 6th. Divide by 10, divide by 60, divide by 24, divide by 365. Barely. 70.6 years. Is that right? Is that what you guys got? Yeah? Yeah. Okay, what if she spent $20 a minute? Well, that would divide the answer by 2. Then that would be 35.3 years, I guess. It's a lot of money. What's my point? Cohen, the whole argument I'm making is, with a medium amount of cleverness, you can build a chain, a fraction conversion chain, figure out a lot. Again, if you can get the right answer using your own method that you've internalized, that you've figured out, fine, I'm good, totally good with that. Totally good with that. But what I have learned is often when kids get to a question they haven't seen before, they're like, well, now what? Write down what they gave you, build a chain. Okay? Rico Fermi, one of my nerd heroes, was a physicist who would often ask his students to solve a problem by making reasonable assumptions about unknown data. In fact, he was brilliant at it. He was very, very famous for making 15 or 20 estimations in his head and coming up with an answer to an obscure question and being really, really close. Let me give you one of his most famous ones. He was part of the Manhattan Project. Does anybody know what's the Manhattan Project from history? First World War, okay, first atomic bomb. He was part of the team that helped design the first atomic bomb, and he was at the first test. And they were trying to figure out how strong the atomic bomb was, and they had all sorts of clever calculations. And Fermi, I kid you not, held a piece of paper up like this, level with him. And when the blast wave, when the shock wave hit them, he let the piece of paper go, and based on how far back it went and the area of the piece of paper, before anybody had run the calculations, he said, I bet you that bomb was about, and he gave an answer, I think he was within 10%. He was brilliant at just making a bunch of lightning quick assumptions. In fact, I have a short little video to show you. Put your pencils down. Look up. So, Fermi problems. I'm going to give you, for discussion next class, you can call this homework, but I'm not going to have you hand it in. This is just to see if you can come up with a good estimate, part of what you'll work on today, and you can work with your partner, if your lab partner, your neighbor if you want, or you can try this yourself. Here are the two questions. Number one, if Pitt Meadow Secondary School has, you know what, we're down a bit, cross out the 1100, let's make it 1,000, because that's a nice power of 10. Has 1,000 students. Estimate the number of pieces of note paper that our school uses in an average year. I've been doing this one for about 5 years, and it's interesting. Usually when I do this, talk about this next class, there's 4 or 5 different, totally different approaches, and they're often very close to each other in the same answer, which makes me think maybe we are actually getting pretty close to the actual answer. So there's one. See if you can come up with an argument that would convince me that your estimate to the number of pieces of paper used by this school in 1 year is accurate. Second one, how many breaths are taken each day in BC? Give me an argument. Again, I'm not going to be caring if you're right or wrong. I'm going to be caring that you have a sound argument, that you have a good argument. Okay. What's your homework? I have 2 things. First of all, I gave you this last class. Some of you said you finished it. Some of you haven't. I will be putting an answer key online in about 5 minutes. What's my website? pittmath.com. If you want to navigate there on your smartphone, it'll be a PDF file. You can look at the answers and seeing if you're doing it right. I didn't attach an answer key to this one. Usually I do, but this one I did not. So I'll also print up a couple of answer keys and have them floating around. You can see if you're doing it right. I want to see see if you can handle these ones in the very, very back. Number 5, number 6, and number 7. So number 5, Mr. Camosi's ancient Italian ancestor was a chicken farmer who wished to purchase a wife. At the time, the going rate for a wife was 2 horses. By the way, I apologize, ladies, but I wanted to build a long conversion chain that was humorous. Please don't ever think that I mean that females should be bought and sold or anything like that. It's meant to be a joke, but I apologize for that. So, 1 wife was 2 horses. 3 horses were worth 5 cows. 1 cow was worth 4 hogs. 3 hogs were worth 4 goats. 1 goat was worth 9 chickens. How much will the wife cost the farmer who's going to pay in chickens? There's enough conversion factors in there. You can build a chain. And I think it might even work out evenly. I have to double check. How many minutes are in a decade? How long in hours will it take you to count to 1 billion, counting 1 number every second? How long in days? How long in years? That's the first assignment. The second assignment is another take-home quiz. This one, again, you're getting class time to work on. Have patience while I get it for you. Sorry, let's try this again. So here's the take-home quiz. Going to repeat myself. I forgot to hit record like a complete meathead. First number here, just like your first one of your quiz, learn from your mistakes. Here's your sig figs. Here, adding and subtracting in scientific notation, which is the biggest pain. What was the method? Unscientific notation at standard form. Write them vertically, lining up the decimals. Get an answer. Figure out what you're rounding to. Where's the first guess? Then write your answer in scientific notation when you're done. Then I have some conversions, so 3 seconds into milliseconds. These are 1-step conversions. Then some more sig-fig practice. Number 6, this is very similar to the question that was in your homework, the Mr. Camosi question. So see if you can figure this one out. If 5 parrots are worth 1 zebra, and 1 zebra is worth 8 monkeys, and 6 monkeys are worth 1 gorilla, and 5 gorillas are worth 2 lions, how many lions are 48 parrots worth? Your hint is write down what they gave you, which is 48 parrots. That's what you'll start with, and you can build a chain. Okay? Then, number 7, can you graph 1, 2, 3, those 4 lines? When you graph them, can you please label each line? So whatever is line A, put a little letter A next to it so we know. Whatever is line B, put a little B next to it so we know. How do I know all of these are lines? Because I don't see any exponents. Psst, almost done. I don't see any exponents or weird stuff. Then, number 8, give me the equations of those 2 lines in slope-intercept form. This is almost your whole test. Almost. What is not on here, which will be on your test, is I'm going to give you some data. I'm going to say graph it. I'm going to say put a title. I'm not going to remind you to do that. You'll have to remember to put a title, put a scale, label your axes. I am going to then say find the line of best fit of that data, give me the equation y equals mx plus b, and I'll ask you to do something with that equation. Pretty much what we did for the page number little lab there, except it'll be a different application. Okay? You got the rest of class to finish this up and get everything caught up and done and handed in. Do not hand this quiz in. We're going to mark it next class.